Does your application require to control sample propagation time between EV12AQ600 ADC and a FPGA, or to synchronize the ESIstream serial link as quickly as possible? In this video, I will demonstrate in simulation how AQ600 ADC and ESIstream serial link protocol will help you to guarantee both a short synchronization time and a short total link latency. Then, we will look at how to ensure a deterministic link latency. To create Vivado project, please check this step-by-step tutorial video selecting 32-bit tickle script to get the shortest link latency when working at a high sampling rate. For instance, in one-channel mode between 4.5 and 6.4 gigasample per second. Each ESIstream package contains a test bench to simulate the high-speed serial link. This test bench is automatically added during project generation. At the end of project generation, you can launch the simulation. It takes few minutes to display simulated signal waveforms. Here is an overview of the test bench. Basically, an ADC emulator is sending a known ramp pattern on each serial lane to the ESIstream receiver embedded in the FPGA. The lane rate is 12.5 gigabit per second per lane. When Vivado simulator is ready, run the simulation for more than 10 microseconds to simulate the two successive link synchronization. I set here a simulation time of 15 microseconds. Once simulation has completed, you can check for each serial lane that the ramp pattern sent by the ADC emulator has been received properly in the frame checking module. So I can expand the frame checking module and the receive data and display for each serial lane the ramp pattern sent by the ADC emulator in an analog view. We can see here that the ramp pattern is received properly. At this stage, we can measure the time needed to synchronize the serial link after sending a sync pulse to both the ADC and the ESIstream receiver. Using markers, we measure a typical synchronization time of 163 nanoseconds between the sync pulse and the first sample release time. Now, let's see how short is the time to transmit samples from ADC analog input to ESIstream receiver output in the FPGA. With AQ600 ADC and ESIstream, you can get a typical total link latency lower than 70 nanoseconds. The maximum total latency of the ADC, including the serial interface, is given in the datasheet and is 142 ADC external clock cycle, so 22.72 nanoseconds with a lane rate at 12.5 gigabit per second. With the test bench and Vivado simulator, we can now determine the total link latency of the ESIstream receiver, including the FPGA transceiver. Using markers, we measure 82 nanoseconds between the end of the ESIstream frame alignment sequence and the release time of the first samples from ESIstream receiver. To get ESIstream receiver latency, we must subtract the PRBS alignment sequence time to get the ESIstream receiver total link latency, which is 41 nanoseconds. So, the total link latency is 64 nanoseconds. Optimizing the output buffer implementation of the receiver, it is still possible to reduce this number even more. Now, I will give you information you need to ensure a deterministic link latency. It means a constant total link latency over multiple power-up and reset. The test bench includes the sync generator plus the sync counter. You can use these modules to release sample data at a deterministic time. The principle is detailed in this white paper, is designed for deterministic latency in ultra-fast digitizing systems. If you need help to implement a deterministic link latency with AQ600 ADC, please contact me using Teledyne hotline email address. This brings us to the end of this video. You have learned how to simulate the ESIstream serial link of the EV12AQ600 ADC. All the useful links are available in the description of this video. And if you have any question or if you need support, please contact me using Teledyne hotline email address. Thank you for watching.